First page result as a Go programming language. That's the official website for Go language. And you can download the Go developer for your OS, Windows, Unix, or Mac. You can download it there. And you don't have to, I will upload this video again, so you don't have to worry about following right now, because you need a time to install it and then set up the environment. And also, the developer doesn't really able to code on your own. So you need, what is it? Oh, yes. So you need a certain IDE, so user interface, to work with the programming compiler. So Visual Studio Code is the most famous and useful, and it's free, and IDE that most people you're using. So I advise you to get this one, or there are other options, for example, Golang or something, but Visual Studio Code always works the best. You can download and then install it on your computer. Don't do it right now. I mean, you don't have time, and I'm not asking you to follow every steps right now. I just want you to watch it, just to know what this look like. And here, let me open up new window. Okay, so let me find this. Git. Okay. So here's my working folder. So whenever you try to work something out, then you need to start from the root folder. And this is my root folder. And again, remember, our task is to find this value. Okay, this is our task. I'm going to show you how you can do it with the Go programming language. So I'm going to open up, make a new file. Oh, sorry, here. I'll make it bigger. So similar to other programming language, Go language could have main.go, which is working as an executable script. And if it's a so if you're going to make an executable file, you have to import the pack. It's not an importing package. So it's you're declaring that your function is in the package main. And you need a main function that is something that contains the script that will be executed when you run this code. So what we're going to do is computing this. So I need an iteration 1,000 times, and I need to compute exponential function and some arithmetics here. So I'm going to use my loop conditions. I'm just showing you what it looked like. I'm not asking you to understand every code. I just show you how it looked like. So I'm going to do it 1,000 times. And what I'm going to do is adding these terms from some variable I declared as sum. So I'm going to add these terms to the sum that I'm going to print out later. So first, I'm going to use exponential function, which is in the math package. It's an external package, but it comes with the Go compiler. And then I'm going to, let's see, assign x to be 2 times I minus 1 divided by 2 divided by n. So here it's 1,000, right? So 2,000, all right. 2n. So that's n is 1,000, so it's 2n. And then I'm going to put that 2i minus 1 over 2n as x into exponential function, and then I'm going to divide it out by 2,000, which is n here. And then once I've done this, that's my sum, and I'm going to print it. That's my whole code. So I iterated 1,000 times to compute these terms and then sum them up, added it to the variable sum, and then print out the sum. So let's run this code on the terminal using the terminal menu. So I'm going to run main.go. Normally you have to assign, you have to declare the module before you run any code, but this is a simple code, so you can do it without any module. So it says it's 1.716 something. Okay, so it might be correct or accurate enough for our answer, but it may not accurate enough. So what you can do is increasing a little bit of more number of subdivisions. So here we used that n as 1,000. So if I change it to n here, and sorry, this is I, and then 2 times of float n. So I'm going to increase my number of subdivision, and if I have to every time change the value n, then it might not be efficient. So I'm going to assign a new variable n to indicate the total number of subdivision here. So this is going to be my new code. So I'm going to change it to 2,000, or maybe 10,000. Maybe that's not going to be that different. But you can see that when I change it to 10,000 from 1,000, then you can see that the answer is slightly changing. But as you can imagine, if you increase the number of subdivision, the answer gets closer to the real value. So you can see that 1.71 is correct, the same, but the third decimal point is now changed to 8. So might be 8 is more accurate number. Maybe how about 100,000? So let's change it to 100,000. Now the 8 is same, so the last digit, the fourth decimal point is changed to 2. So maybe it might be accurate up to fourth decimal. So you can say, okay, so I don't know the exact limit because it would be irrational number, but I can approximate that irrational number up to fourth decimal digits, like 1.7182, or is it? Yeah, fourth decimal point, 1.7182. So that's how you get the answer. So what you want to get is not nice form of the answer. We want to get an answer, right? How you obtain an answer and how you represent your answer depends on your method. Even if you get the answer in a nice form, so-called, let's say a formula involving like pi or e or something, other fancy formula, in order to make it sense in a real life, you need to have a certain value, real value, right? So then you have to get the number again by taking it into a calculator or something. So why not just obtain the numerical answer directly? You can do it. You can get it answer with following the definition of integration directly. Okay. So the next time